AI cannot teach. At least it can't do so at the level of great human instructors. But cognitive and immersive R&D is driven in part by the doctrine that together, humans and machines as co-teachers can reach transformative pedagogical heights. What you're about to see depicts engineering toward such collaboration in the realm of mathematical physics.
Sensors in the cognitive classroom provide their data to a translator that in turn supplies the overseeing ambient AI with declarative knowledge that constitutes what this machine sees with its mind's eye, shown on screen here.
So today we're going to study the effect that motion has on clocks in the special theory of relativity. So here's our initial setup. We have a space-time diagram and two twins, Alvin and Bobby. We're going to assume that Alvin stays on Earth and Bobby goes off on a spaceship in the space-time trajectory that's shown on the diagram. So let me ask you this question. When Bobby returns to Earth, are they still going to be twins? Can you answer that, Matt?
I would assume so. I mean, they're going to be twins for life, aren't they?
Okay, can you prove that?
Sure. So we have Bobby and Alvin traveling through space and time, and this represents their mechanical time. And so we can say that the mechanical time of Bobby and Alvin are equivalent to their biological clocks. And so long as their biological clocks stay in sync, therefore they remain as twins. And so on Bobby's trip through space, he has two friends, Jack and Jill, and they launch at the same time as Bobby.
Understood, Matt. Keep going, please.
The heterogeneous diagrammatic sentential proof verification system VIVID is supplied with a first-order axiomatization of the special theory of relativity. VIVID specifies a natural deduction calculus that allows us to identify correct and incorrect steps of reasoning in a diagrammatic proof. Here we find the VIVID interpreter extracting sentential information from the diagrammatic representation supplied to it.
Jack sends Jill a light signal when Jack launches, and it reaches Jill at time p.
Okay, Matt.
And so Bobby also sends Jill a light signal, and it reaches Jill at the same time p.
Correct, Matt.
All right, can you tell me where Bobby sends the light signal from?
Well, this is what makes my point. So Jack and Bobby both send Jill a signal, and it reaches her at time p. And we know Jack sent his signal at launch. So therefore, Bobby must have also sent his signal at launch, and it reaches Jill at time p. And this would mean that Alvin and Bobby's clocks are still in sync, and that Alvin and Bobby are still twins.
Sorry, Matt, but this violates the light axiom I was given. Bobby's signal would have to travel at slower than the speed of light to reach Jill at p. I'm deleting that step.
Okay, let's give somebody else a chance to complete the proof and write down a correct step. Oh, Rikia, why don't you come up to the blackboard?
Sure. So I think this is Bobby's signal. So it is sent out at point Q, which is well after the launch. By Jill's testimony, Bobby's clock reads 0 at time Q, but Alvin's clearly doesn't. So their clocks are out of sync, which explains that they are not twins.
Excellent, Rikia. I am able to infer from my observations that their clocks go out of sync.
So I think that concludes the proof that we have. Let's ask the AI to show us the completed proof. AI, can you show us the completed proof?
This concludes the proof.
Shown on screen is the complete proof in VIVID syntax, which was formally verified by machine. The proof goal, that moving clocks go out of sync, is shown deduced in the propositional calculus from our formal definitions and VIVID's observations.
Many thanks to the institutions that have made this R&D possible and are indeed continuing to make it possible. Rensselaer, IBM, the Rare Lab, the Smart Lighting Engineering Research Center, and for considerable funding, AFOSR. Thank you.